So first, let's go with this polynomial. We have the function f of x equals 3x squared minus 4x plus 1 and the point 2.5, 2.5, and we're going to find out what f prime of 2 is. So to calculate f prime of 2, we can use the limit when x goes to 2 of f of x minus f of 2, x minus 2. And that essentially is going to be the function 3x squared minus 4x plus 1 minus 5, which is the value of f of 2, over x minus 2. Since this is a function that is going to go to 0 on top, 0 on the bottom, then we need to factor out and eliminate the x minus 2 from the bottom. This in the top subtracting becomes 3x squared minus 4x minus 4 over x minus 2. And now I need to essentially factor out the polynomial on the top. This polynomial on the top can be factored as x minus 2 by 3x plus 2. The reason why I know this is because if you plug 2 in here, you're going to get a 0. So that means that this has to be a root of this polynomial. So you can factor in x minus 2, and the rest is whatever is going to be left after factor that. Now, if I factor this, then I get to cancel this out. And then finally, this is going to be the limit when x goes to 2 from 3x plus 2, which is going to be 3 times 2 plus 2, or 6 plus 2, 8. So this means that f prime of 2 is going to be 8. Now, if we had, by any chance, something that tell me calculate a tangent line at this particular point, at the point 2,5, then what I'll do is I do y minus 5, which is the y point, 8 times 8, which is the derivative, x minus 2. And with that, I get to find out what the equation of the tangent line is at that point. Okay. So, but this is using, again, this approximation to the derivative in a point. I can also use the other formula. So now let's make an example with the other formula. And let's go with this function here. Let's take the function square root of 5x plus 1 in the point a equals 7. And we're going to find out what f prime of 7 is. So because I want to use the other formula, I'm going to use limit when h goes to 0 of f of 7 plus h minus f of 7 over h. And so I plug now on 7 plus h. This is limit when h goes to 0 of a square root of 5, 7 plus h plus 1 minus f of 7. And f of 7, if you plug 7 here, 5 by 7 is 35 plus 1, 36. Square root of 36 is going to be 6, so you get a 6 in there. So again, we have a situation where we have a root, and we need to get rid of the root to do something with the h below. So we're going to be using the conjugate technique for limits. Now, if I explore what this is overall, this is going to be 5h plus 36. This is what this is going to produce at the end, minus 6. And so now I'm going to be multiplying top and bottom by 5h plus 36. Since I have the minus, I'm going to use the plus. So I can use the difference of the squares to produce the intended desired, which is a square in the square root. And so this produces limit when h goes to 0 of 5h plus 36 square minus 6 square. Remember, we're using the difference of a square, a squared minus b squared is a minus b times a plus b. So this is what we're using here. Now at this point, since I can get rid of the root, we get limit when h goes to 0, and this produces phi h plus 36 without anything in the way, and 36 is 6 squared. So now I'm going to get to cancel that 36 as well, and my final limit is going to be phi h over h, which clearly is going to produce limit when h goes to 0 of 5, which is going to be 5. Okay, so in this case, f prime of 7 is 5. Now, this is something that we've been doing point-wise for points in a specific, but we can also do and use the definitions to find the general function of the derivative of a given function. So for a given the function f of x, we can find the y dx, or f prime of x, which is the same thing, the function of the derivative. And the only difference here is that we'll use no point at all, but we'll use just the formula. So in this case, it's much more simple to use just the general formula. So f prime of x can be done by the limit when h goes to 0 of f of x plus h minus f of x. So we don't use any point, we just use x directly, and we just calculate the limit from there. This limit is going to produce a function of x, since notice that the limit is only plugging in h. So now f of x plus h, what is it? In every position where we have an x, we plug in x plus h. So we got minus x plus h squared plus 4x plus h minus 3. And so this is f of x plus h, and then minus and minus x squared plus 4x minus 3. And so that is the two functions. Now, of course, I gotta do some algebra here to just simplify what I'm doing. This is gonna be a little bit long, but this is essentially minus x squared minus 2xh minus h squared plus 4x plus 4h minus 3. And over here, I'm gonna get plus x squared minus 4x plus 3. So now I gotta cancel out similar terms. Notice 4x goes away with 4x, 3 goes away with 3, minus x squared goes away with x squared. So there's a lot of elimination of things. And do you know, if you're in good track with the elimination, if at the end everything that is left is going to have h on it? So at this point we can see that. We can get this, this, this. And it's a good thing because we're trying to cancel out the h below. So we get to factor that. We get minus 2x minus h plus 4 over h. And that's limit when h goes to 0 minus 2x minus h plus 4. And so if we plug in here, we get minus 2x plus 4. And so notice that this function that we obtain here is now the function f prime of x. So every time that you need to obtain the general function derivative by using definition, this is what we do.